Let me try. Started by you. Is it recording? I'm not sure how
Yeah,
to check it.
yeah.
It's,
You see the
but
red
they didn't.
red mark on the
Where's
top
the red?
next to the time.
Mm, Next to the time. Oh, okay. All right. All right.
Yeah.
So I think we should start, okay? All right. So
Okay.
I think since Dr. Nur Azima not around, so I think we take over. Okay. So Assalamualaikum warahmatullahi wabarakatuh and good evening to all the students and also to our speakers. Okay. So we have the first session for today. The first speaker is Dr. Abinesh from University of the West of England. Okay, so we will have the second speaker, Dr. Abdul Majid. Okay, later on we'll give his what topic. Okay, so for the session from Dr. Abinesh is half an hour, and followed by Dr. Abdul later on, and then we will have a break 1 hour. Then we will continue for the second slot. Okay, so this is considered the first slot, but we have two speakers. Okay, so for the topic that Dr. Abinesh will deliver is about the beyond heart his mental well-being in the construction education. Later, Dr. Abinesh will introduce yourself maybe. Okay, so I give the floor to you. Enjoy class and please ask question a lot. Okay, to him. Okay, so the floor is yours. Thank you,
Yeah,
Dr.
thank
Abinesh.
you, thank you. Good afternoon and and good morning to few of you who are joining from a different place. But
Oh
very
yeah.
warm hello to all of you joining from Malaysia and beyond. So before I begin, keep note on the format. Since we are doing it online, please feel free to drop in your questions in the chat as we go. I'll do my best to come back at the end of the session to answer them. Now, today's event theme is, it's construction safety and health management, and most talks you will probably hear today will be quite rightly focused on physical side of safety. But we know safety and health is a broader conversation than that. So well-being matters too. And the construction industry, as many of you know, has one of the worst records of any sector when it comes to mental health, anxiety, stress, etc. So that's especially true for young professionals and graduates entering the industry for the first time. So today I would like to take you in a slightly different direction. I want to talk about well-being, specifically well-being of the next generation of built environment professionals like you before you even reach to the construction sites. So the title of my talk is Beyond Hard Hats, Mental Well-being in Construction Education. It's about a VR intervention we developed at the University of West of England, Bristol, to help students overcome the fear of public speaking, and in doing so to address a well-being challenge that affects a surprising number of students in our discipline. So before I dive in, let me introduce myself properly. I'm Dr. Avinesh Prabhakaran. I'm a senior lecturer in building information modeling at University of West of England, Bristol. I came into academy after probably 7-8 years of industry experience working as project engineer, project manager on construction projects across the Middle East. And that experience really shaped how I teach, how I do research these days. And my research mainly sits at the intersection of immersive technology, construction health and safety, design, communication, coordination, etc. And these researches have resulted in various tools looking at probably construction safety, design communication, student well-being in built environment, etc. And these works have been recognized through several awards, most recently the UV's Staff Award in the category Innovation, and the RISE Award in Education and Training in 2024, which was specifically for the Stagecraft tool, or the project we will be discussing, we'll be talking shortly.
Congratulations for a lot of awards.
Thank you. A quick intro to the team. So the project I'm going to talk was funded by University of West of England through the UV Pedagogy Project funding. And I was the principal investigator, supported my co-investigators, Colin, Patrick, and Abdul. So we were the team doing this project. A bit of a background. I want to give you a background from the educational perspective and both and as well as the industry perspective. So from the educational side of it, oral presentation and public speaking skills are important predictors of a student's classroom success. The relevance of these skills, particularly in the UK higher education context, and I think it might be similar in Malaysia as well, cannot be overemphasized, considering the fact that most of the modules uses probably presentation as a means of evaluating students' understanding of the subject and their ability to develop and deliver engaging and persuasive arguments. So this requires students to participate verbally in both small and large group settings as a way to improve their learning experience. And also these interpersonal skills can positively influence a graduate's employability. So we're not just talking about grades, but we are also talking about how does it impacts their job beyond universities. But studies indicate that a large proportion of students in the UK, and I think globally, when you look at the figures, will be something similar. Higher education experience a fear of oral presentation and public speaking, resulting in students missing out learning opportunities by avoiding interactions, leading to poor learning experience, which in turn affects their grades and future job prospect. Um, Crucially, the impact of this fear goes well beyond academic achievements. For instance, this persistent fear of public speaking can contribute to broader mental health challenges, including elevated stress, maybe low self-esteem, feeling inadequacy, and even symptoms of anxiety and depressions. For some students, this fear can influence their fundamental decisions about higher education, like deterring them from enrolling in certain courses, participating in group work, or even attending university altogether. And then from the industry perspective, these interpersonal skills can positively influence a graduate's employability. As you can see from the right side of the image in the right side, a survey conducted among 600 employers uh, indicated that oral communication and presentation skills are two of the topmost skills they look for while recruiting a graduate. So these fears are also affecting a large proportion of UK graduates. Like I said, it might not be the case of UK, it might be global as well, from applying for jobs that require you to have presentation skills. And most of the jobs these days require presentation as a key skill. And interestingly, this fear of public speaking also affects their employees' income and career advancements, because if there is the promotion round coming, some of them are feared to apply for because those job roles require to have these skills. Now, educational experts and employers agree that graduates are entering the job market with a significant gap in oral communication competency, and that higher education should be doing more in effectively training them. With this in context, this is where Stagecraft tool comes in. So what we have done is we have developed a novel VR tool nicknamed as Stagecraft that gives students a completely immersive environment where they can practice their oral presentation as many times as they want in a safer environment where they are not being judged. Because most of these fear come from the feeling of being judged by your peer or by your tutor. So Stagecraft offers that safer space. But it's not just a VR headset and a virtual room. We have combined three key technologies that, when they work together, do something much more powerful than any one of them alone. Now, the first one is immersive VR itself, which puts the student inside a realistic lecture theater or a seminar room with virtual audience. I'll show you some video clippings from the tool itself, which will give you more clarity. From the moment they put the headsets on, they are presenting, their body responds as if it is real, because to their brain, it largely is real. The second technology we have integrated to Stagecraft is artificial intelligence, specifically generative pre-trained transformer models or GPT models, integrated through OpenAI and Amazon Web Service. The AI generates contextual questions during and after the presentation so that the student get the experience of a live, unpredictable audience, not a scripted exercise. So it is preparing them not just to practice the presentation, but also how to face a real life audience with questions. The third feature we integrated into Stagecraft was eye tracking and head tracking, which lets us capture what the student is actually doing during the presentation. For example, where they are looking at, are they making eye contact with the audience or staring at the floor, or are they scanning the whole room or fixating on one corner? And these are being presented in the form of a heat map, which I'll also show you in the later slides. How do they look like in real life? Now, these three elements feed into a real-time feedback loop. The students receive meaningful evidence-based feedback on the things that actually matters in the presentation, like tone of voice, eye contact, audience engagement, pacing, use of filler words, etc. Now, also critically, we built Stagecraft to be multi-user. So we know VR have got this inherent limitation of putting on the headsets and you are being alone in that space. But Stagecraft is different. It is built using photon networking, which means students can practice together. They can take turns presenting, give peer feedback, and learn collaboratively. This matters because public speaking sometimes that anxiety is often worsened by isolation. By making the experience social, even in VR, we are addressing the well-being dimension as well as the skill. Now, what we ended up with is a safe, a repeatable, intelligent social environment for students to confront their fear, practice the skill, and build confidence, all before they even step into, for example, real life lecture theaters or an industry boardroom or a real construction site briefing. And we followed a bit of a methodology. So we followed a three-phase approach in the development of Stagecraft. The first one was a desk-based research, which is basically looking at what is the current state of fear to understand, to have a benchmark or a baseline, to understand what is the current level of fear, and the impact of those fear in the higher education in the UK. So we did a series of literature investigations to find out, and it reiterates our initial findings, saying that there's quite a high level of fear in the higher education. Then what we looked at was to look at what is the current use of VR in anxiety related treatment, because VR has been used for treatments like phobias with hydrophobia or claustrophobia, those kind of treatments, and for heights and things. So we have looked at some of the researchers which have used VR to apply them in the context of anxiety treatment. So we have looked at those and how they are applied and how the tool looked like. Then once those informations were gathered, we moved into the phase two, which is mainly the development phase, where we captured the requirements and the approach to develop it. The first approach we wanted to implement was to scan the physical classroom into virtual environment. Now, we could have done it by just modeling example classrooms by from our imagination, but we didn't want to do that because we wanted to have realistic UV classrooms, physical classrooms transferred into virtual classrooms in the environment, so that our students, when they practice, they get the realistic experience of as if they are presenting in a space they are familiar of. So we used the scanning methods, which I'll show you in the next slides, to get physical classrooms into virtual environment. Then we integrated AI, specifically GPT, then Amazon Web Service and eye tracking integration, and built the app, loaded it into a standalone headset, which is Oculus Quest. And then phase three, it is currently ongoing, but we have done some testing as well. So we have planned to do a one group pre-test, post-test, where we measure a number of students' current level of fear, then give them the headset for an extended period of time to use it, then test them with the same questionnaire to see if their fear, if the treatment has been effective and has the score for the fear have come down. But also, apart from those one group pre-test, post-test, we have also done some usability, user experience, and technology acceptance testing, which I'll show you what the results come out in the later slides. So that's basically the three-phase approach for the development. In terms of scanning the virtual environments, the physical to the virtual environments, we used Matterport to scan our classrooms. Then once scanned, we moved it into a couple of middleware softwares like Blender and Revit to clean the model, and then get it into Unity software, which is our primary game development engine. And then the end result is a virtual representation of the physical UV classrooms. These are some of the more examples. So what you're seeing on the left side is physical classrooms, and then on the right side is the virtual representations of those classrooms within Stagecraft environment. developed through scanning. A bit about the tools interface. So when you put on the headset, you have been presented with these options. What you're seeing on the first, let me put my laser pointer so it will be easier. So what you're seeing here is the audience. So what the students can do is they put on the headset, they can set the level of audience, virtual audience. So when you're in the classroom, what you're going to see are virtual humanoids. They're intelligent humanoids because they are the ones who ask the questions at the end of the presentation, but they also behave intelligently like real life, how real life human will behave in a classroom. So you can set the number of audience in the class. If you keep it to full, you will have a house full class. If you can keep it to low numbers as well. You can set the distraction level. If you keep it to 100%, you're going to have a very noisy, distracted audience, but that is to help to prepare students with similar kind of environment. What you're seeing here is the keyword. So before they start the presentation, they have to enter at a maximum of 5 keywords, at least one keyword, which is basically the theme of their presentation. It could be whatever theme they think that the presentation is, because GPT will pick those keywords and then generate questions randomly as they present. They can also set the number of questions, how many questions needs to be asked. So they can set it to 10, maximum 10, which means 10 questions will be asked by the virtual audience. They can keep it to minimum at least one question. Then what you're seeing here is the room selection. Because it's a pilot project, we didn't transfer every physical classroom into virtual. What we did is we picked different varieties of classrooms. So you can see some classrooms are 294 seating capacities, like big lecture theaters, to small classrooms which have got like 37 seating capacity. So we picked on the variety rather than the quantity or the number of classrooms. Then, like I said, it is a multi-user system. So up to 20 students can join the same classroom as a group presentation or to observe their peer presenting. So you can use different types of avatars, how you want to be represented in the virtual space. You can enter your name, username, which will appear over the avatar's head when they are in the space. Now, these are some screen grabs from the tool itself. So what you're seeing here is the virtual classroom. The slides have been loaded. And what you're seeing here, this one is at the end of the presentation, the questions is being generated, but when you put on the headset, you can actually listen to the question being asked by the humanoid, but you can also see the mass text so that you can read from or listen to it and answer those questions. Now, these questions are generated by pre-trained transformers, so they are random, and each time when you present, it's a different question based on your topic. In terms of the eye tracking, I told you, which measures the engagement with the audience. So what you're seeing here is a heat map where the user was looking at. So the blue patches indicate very brief eye contact with the audience, but the red, green, yellow indicates a more longer time of eye contact with the audience. So it allows you to look at that whole audience to see where you are looking at. Because when you are in a state of fear, what happens is sometimes you look at on the floor, or you look to your slides, or just look at the scripts and read through it rather than engaging with the audience. So heat map offers that holistic view of where you were looking at throughout your presentation and where did you miss out. What you're seeing here is at the end of the presentation, you are getting a overall score on your like pace, your filler words used, long pauses, etc. So that is the overall score system you're getting at end of the presentation. So this is, I hope it will play. Yeah, so this is the tool itself. Let me turn off my how it looks like when you put on the headset. I'll just quickly skip through some of these. So these are the options you already saw. You can set the level of audience within the system. So you can move that slider to keep it to 100. You can enter your keywords, and once you are in the classroom, you can just present as if you present it in real life. So you can use your controllers to click through the slides like you will normally click in any presentation. You use your controllers to click through your slides. And at the end of the presentation, what you're seeing at the top, those white boxes are audience with questions. So they will, when you click on them, they will ask the questions. You answer all the questions. Once you finish answering the question, you are being presented with this heat map plus the overall score of your presentation. So for example, what you're seeing here is the audience on the right side. I didn't pay any attention, so you don't see any heat maps there. So I was not looking to that audience at all. But on the left side, you'll see I was fixating on few audience in the center. So that is an essential feedback I'm getting, that I need to be more engaging with my audience um, in the presentation. Now, in terms of the findings, so does it work? We did a preliminary. We did collect some qualitative and quantitative data as well. So the qualitative data, for instance, the quantitative data, we looked at basically what is the current state of fear, and the results indicate that there's a significant number of students with extremely high or high level of fear. That reiterates our findings from the literature. So it's nothing new, but we just wanted to have that baseline established. And then from the qualitative data, we did some interviews after students using the tool. Very positive results, like students have said, the environment is highly capitative and immersive. They're easy to learn, engaging experience. They felt involved. So quite a lot of positive responses we got from there. And also some of the themes that came out of the qualitative responses are like highly effective, feels very safe in the space, which is very important, because when you are one of the major reasons for this fear is the feeling of being judged by others. So if the students are feeling very safe within the environment, it means that it is helping them to develop those skills. Now, it also increased their confidence. So these are some of the themes which came out. Some of them said ultra realistic, feedback system is great, feels like in real life classrooms. Now, also a few quotes from the presentation, from the interview itself. So the student said immersive experience was realistic, again, safe and comfortable space, which was a constant theme which popped up in most of the transcripts we got. The confidence level was high. International students specifically found it the concerns about pacing, audience engagement, crowd management, all those were effective with stagecraft. Some of them even said the AI generated questions and the heat map which you saw were particularly helpful, offering valuable insights. A few more feedbacks like safe environment, heat map, engagement with audience, simulated audience interaction, etc. So these are some of the qualitative feedback we got, but also in terms of the quantitative one. So we ran a controlled evaluation with 56 students at UV using three forms of validated instrument. The first one was the system usability scale, which basically looks at whether the system is usable. Then we wanted to look at the sense of presence. So sense of presence in the VR context is basically believing in the virtual environment and getting involved with the virtual environment and forgetting about the physical space. So we wanted to look at sense of presence, because if you don't believe in that space, then the effectiveness of the tool will be less. We also wanted to look at the technology acceptance as well, because if we have to deploy this tool, we want to understand whether students will be willing to adopt it to use it for an extended period of time. So across the three-dimensional, some of the things we found is for the usability scale, stagecraft scored really high usability level, which is 75. Which is well above the 68 benchmark of any acceptable system, and falls within the good usability range. 92.9% of the participants found it very easy to use. In terms of the presence, the numbers were striking, like 96.4% felt presence in virtual environment, which is great, because that means they are actually believing in the space and forgetting about the physical space. Now, 92.9% felt involved in the experience, and there was very less negative effects like motion sickness, because motion sickness has historically been a major barrier in any forms of VR tools. In terms of acceptance, because like I said, we wanted to know if they will be happy to accept the tool and use it for a longer period of time. Almost 90% said they would recommend stagecraft to other students, and 96.4% found it made presentation practice more interesting than the traditional method. So at the headline level, the answer is clear. Stagecraft works, it is usable, it is immersive, it is engaging, and student endorses it. But the more interesting story isn't whether it works, it is about who it works for and why. So when we designed stagecraft, we had one user group in mind more than anybody else. which is the students who genuinely struggle with public speaking, the ones who experience that clinically significant anxiety we talked about at the start of this session. So we built a deliberate question into our analysis, which is, did anxious students experience stagecraft differently from the confident ones? And the answer we got from the analysis is yes, they experience it differently in two important ways. The first finding is on the left side of the slide. Um, Anxious students found stagecraft significantly harder than their confident peers. They perceived very low level of ease of use, lower spatial presence, lower ecological validity, all statistically significant. Statistically significant. Now, on the face of it, that looks like a problem, but it is actually consistent with how anxiety is known to operate. Like, for example, pre-existing fears activates within us a system called the threat detection system, which competes with our cognitive resources needed to navigate the environment. The very anxiety we are trying to treat is also what makes the entry into the treatment harder. It's a known mechanism in the VR and anxiety literature, which is normally called as the cognitive affective load, which means when you're very uncomfortable with the space, you feel the space is not very, or the space is very hard to or the tool is very hard to use. But here is a finding that really matters. It's on the right side what you're seeing. Despite finding stagecraft harder, anxious students actually valued it just as much as the confident students. So no difference in perceived usefulness, no difference in attitude, no difference in intention to use it again. Or in other words, the students who struggle the most also wanted it the most. This, I would argue, is the signature of a well-being intervention working as designed. The barrier is felt, the value is recognized, the motivation is there. Now, our job as designers and educators is to lower that barrier, to scaffold the anxious learners, to start them with smaller, less attentive audience, and gradually expose them to a fuller ones. The way normally how any exposure therapy has worked for decades in clinical practice. So that is the direction we're looking to move when we are going to extend this testing into our post-test stage. So gradual exposures and move forward slowly. In terms of stagecraft, what is next for stagecraft? So we are also planning to integrate smart watches and facial mapping to the tool, because we wanted to see how does this system, how does the biosensing readings from the user's body can help overcome their fear by, for example, the virtual environment evolving to a person who have got higher level of fear. So this is our future development plan, to integrate bio smart watches and facial mapping to help to customize the help basically for individuals' requirements. Now, before I close, I wanted to share one more thing with you. Everything you have seen today, the project, the findings, the well-being implications, it's within a much bigger conversation happening across the AEC industry right now. And earlier this year, together with my colleagues Abdul, Colin, and Patrick, we put that conversation into a book. It is called The Applications of Immersive Technology in AEC Industry. It brings together contributions from researchers and practitioners across the world, covering exactly the kind of questions we have explored today: immersive learning, construction safety, design, communication, sustainability, and importantly, the human and well-being dimension that often get left out in this conversation. Now, if anything I have shared today have sparked your interest, whether you're thinking about your own teaching or your research or your industry practice, I would warmly invite you to take a look. The QR code on the screen will take you straight to that. So to close, across this work, all the VR works we do, what I keep learning is that technology is the easy part. The hard, more interesting, and more important work is understanding the people we are building it for. So thank you very much for joining me today, and I would love to hear your questions and your reflections. Thank you.
Okay, Dr. Zima.
Yeah. All right. So thank you so
I'll take some
much,
questions.
Dr.
Yeah.
Yeah.
Oh,
Thank you so
okay.
much, Dr. Abinesh, for the very wonderful presentation. Okay, we
Thank you.
open question to the student. Student, do you have any question?
While
I
waiting for the question, can you turn on the camera as well, the students?
Yeah, just now
I
I
hello.
hear
I hear
someone to
someone
talk.
to talk.
Yes.
Yeah, right.
Right.
Okay,
Okay,
continue with it.
continue with it.
Good morning. Good morning from the UK, and good morning everyone. My name is Bridget, and today I wanted to not share, but ask you a question. Do you ever consider to have that VR into Malaysia as well?
It's a good question. Uh, we haven't thought about from a research perspective yet, but the tool itself is applicable in every country's context. So if we get an opportunity to submit a bid in the future, we'll definitely consider. But also, Lina, when I come to Malaysia, I'll try to bring it along so that probably your students could also try. So you can test it out when we do the visit in July.
Okay, that's great. Please bring it.
Yeah.
Yeah. Any other question? Okay, maybe can I ask?
Oh
Yeah.
yeah, yeah, sure.
Yeah. All right. Okay. So just now I see that for this stagecraft, okay,
Yup.
it allow user to adjust the audience size, right, and the distraction level. Okay, but in the real presentation, okay, we the student not only anxious because they have to speak, but also because of they have the students, the audience in front of them, right? So how stagecraft is designed, the features are designed to recreate this kind of presentation or pressure from that.
Yeah, good question. So, yeah, audience pressure is probably one of the major reasons for this fear, right? So, like I said in my presentation, the audience are intelligent, so they are not just sitting as like statues. They are animated audience. They move. So, if you set the distraction level, for example, to full, some of the audience, their phone will ring. They will be talking. They will be talking between them. So, we have as developed the system so that they replicate the kind of distracted audience you get in real life. So it is not an audience just sitting there as still statues, but they are actually moving and doing and interacting in the way how they will do it in real life, because that is
Interesting.
one of the key thing we wanted to simulate, because that is the pressure you get. But because even in the class when you're teaching and if the students are talking, it
Mm,
distracts you, right? And a lot of things goes through your mind as well, like is my session interesting, or is it boring? Are they talking because of that, or is there any question? So we wanted to simulate that similar situation where how do they manage such similar kind of situations. Okay, but within stagecraft you cannot tell them to keep quiet. All you can is to build your skill to face that.
mm, yeah. All right. Okay. So very
Thank you.
interesting. I hope that we can bring the
Yeah.
stagecraft here. Yeah. Soon.
All right.
Okay.
Yeah,
All right.
definitely.
Thank
Definitely.
you so much, Dr. Abinesh. Do we need to
Thank you.
take picture first, Dr. Lina?
Yes.
Yeah.
Okay. So please turn on the camera because we have Dr. Abdul Majid as well session. So and Dr. Abinesh might left after this. So
Yeah.
we try to capture the photos all together since all the speakers are here. So everyone, please turn on the camera so that we can capture together. Okay. One, two, three. Smile. Please turn on everyone because the what I call the view looks like empty. I mean no camera. So it's not nice. Maybe Dr. Azima can take another mode because I can change another mode as well. Let me try to put in the seat. Okay, one, two, three. Now I put all everyone in the class. There is another mode. Okay, one, two, three, smile. Okay, another view. Wait a moment. Let me try again. Option. Okay, one, two, three, smile. Okay, so I think it's good enough. And Dr. Zima, you can moderate for the next session. Thank you.
All right.
All right.
Thank you. Thank you
Thank
all.
you
Yeah,
so
thank
much.
you, Dr. Abhinesh, for your
Thank you all. Thank you all.
great presentation.
Thank you.
Yes. Bye-bye.
All right. So I believe Dr. Abdul Majid Mahamadu already here. Are you here?
Yes, I am. And can you hear me?
Yes, we can hear you. Can you share your slide?
Okay,
All right.
fantastic.
I think
So please
already
confirm
I
to
saw.
me,
Yes, we can see your
can
slide.
you can see my okay. All right.
All right.
So I'm gonna have to move my setup around a bit so I can my screens are a bit complicated here, but I think I'm fine. I'm fine. I
All
think
right. All right.
uh okay. So do let me know whenever you want me to start.
Okay. All right. So thank you so much. Okay. We are moving on to the next session. Okay. So the next session is regarding immersive technology application for construction safety management. Okay. Presented by Prof. Abdul Majid Mahamadou from UCL UK. Okay. So I think without further ado, the floor is yours, Doctor. Thank you.
Okay. Thank you very much, Nurul, and good evening to you in Malaysia. It's actually morning here. It's not yet afternoon. But I'm very pleased to be doing this again. I think I did it last year. So my talk is also going to center on the use of immersive technologies, primarily VR. So similar to what Abhinesh presented in his talk. But mine would focus more on safety management in the construction context. So just give me a second so I can get my screens to, yes. So are my screens moving? Are my slides moving?
Yes, yes, yes. I
No,
saw
okay,
just
all
now
right,
yes
fantastic.
moving, but
Okay, all
right.
right, fantastic. Okay, all right. So I'll start then. So anyway, so my name is Abdul Majid. I'm a professor of innovative and industrialized construction here at UCL. I until recently, I'm outgoing program director for our MSI in construction project management. And in terms of research, I do a lot of research that looks at the application of emerging technologies for improving construction and the way projects are delivered. And a key part of some of the research, I do is looking at how safety on construction projects can be improved, particularly the application of emerging technologies. And one of the emerging technologies that has been the focus of our research over the years has been immersive tech. So I'm sure I've worked with Abby and some of the other colleagues he mentioned in his presentation. So I'm sure you can see some of the portfolio of work that Abby mentioned. So these are actually works that we've done together. So Abby has talked to you about one particular one. I'll talk to you about some others. But before I start, so my assumption is that most of you know what VR is. But again, I thought it would be useful for us just to do the basic introduction and definition of terms for the benefit of those who don't. So, what is immersive technology? So, immersive technology includes virtual reality, augmented reality, mixed reality, and also augmented virtuality. More recently, it's been referred to as extended reality. So, that's another term that you would hear. But generally, these terminologies describe a number of technologies that allow you to create simulated virtual experiences with digital elements that people can interact with. And so they provide an ability to visualize information beyond three dimensions, so more in an immersive way, or other times with an integration of both immersive and other non-immersive approaches. They are done by a number of devices, normally which simulates the visualization, but also there are also tools that can help you visualize other things, or experience, not visualize, experience other things such as sound, as well as even maybe smell or the sense of touch. So basically, that describes immersive technologies. These are the categories of immersive technologies that normally get talked about. So we've got a virtual reality, which normally is where you completely replace the real world environment with digital simulation. So whoever is immersed in a virtual reality simulation doesn't see the natural world. They see only the virtual elements and they can interact with it. At the other end is augmented reality, where you overlay digital objects or elements onto the real world. Okay, so there are also a number of interesting applications. If you look on the screen, you would find at the bottom right of the screen, you'd find a tablet, which is used to overlay a piece of furniture into real world. So for example, you can use that to visualize what furniture you're going to purchase would look like in your space. And the middle of it is a blend of both immersive, which is the digital content, and the real content in a more uniform way. So there are elements of it being immersed, but also the two worlds interact. And a more recent one that's emerging is what is termed as augmented virtuality, which is where you've got primarily a digital environment, but then you can overlay little bits of the real world into that environment. So that's the definition. So you can realize that these technologies range from fully simulating digital views for people to blending the digital views with the real world, how we visualize things, and that's what together are sometimes called immersive technologies, or I think maybe the better term is extended reality technology. So these are the categories. Why are these technologies becoming important in terms of the tools we are developing or deploying them in managing safety or even deploying them in managing health, as was demonstrated by Abhinesh in his talk? So there have been some experiments where virtual reality has been used. So particularly the image you find on this screen are images of brain scans, okay? Brain scans while someone was using virtual reality and specifically for a driving simulation. So simulating driving a car, not real, but in a virtual reality application. And what these researchers realized was that virtual reality activated parts of the brain in a very similar way as your brain gets activated when you see things in the real world, because we see things in the real world with depth perception in 3D. However, virtually, usually information is communicated to us on screens. So, for example, laptop screens or computer screens. So, although the information might be in 3 dimensions, you are essentially looking at it on a 2 dimension screen. Okay, so it's still not real. So when you use tools like that to communicate information, to develop training, to develop applications, it sometimes doesn't mirror the real world in the same way as when you use immersive technology, where you are fully immersed and your ability to see things at scale are slightly more realistic. And so these concepts mean that virtual reality simulations have something that we call better presence as well as better realism. Okay, so as a result, we are able to use it to simulate things that are more similar to the real world than we would do on 2D screens. So I think there was a brilliant question to Abby about whether or not having virtual audience is similar to having real audience. So the difference is if you have virtual audience on a 2D screen, you will not be able to simulate a near real experience like if you have virtual audience in a simulated virtual reality environment, because research has found that it stimulates the brain in a very similar way to the real environment. So not perfectly, but it's nearer realism than other means of communicating. So if you see the what I put on the screen, you realize this is probably an old lady that's been subjected to some images that are not very comfortable on virtual reality, and she's reacting almost as if it's real. So those who use virtual reality, especially for playing games, probably have experienced these sensations where you're almost thinking you are visualizing something real. And this used to be not as good as it is now, but the technology is improving, so the level of realism is also improving. Um, so now let's move on. So what's the what's the relevance of all of this? So yes, if we manage to make virtual reality simulations a little bit more real, what is the advantage, especially in the construction context? What this means is that we would be able to simulate situations on construction sites, including risk on construction sites, in a more realistic way. And we can use that either for the purposes of planning construction sites, so that workers can navigate the construction sites in a safer way, or we can actually use it to train workers about risk they are expected to see when they appear on a construction site. And virtual reality allows us to replicate the environment such that it's very similar to the exact environment they are going to be working in. And then we can subject them to virtual risk. The advantage of a virtual risk is that if they actually do something wrong, they will not end up getting hurt. Whereas if we subject them to training in real life environments, then it becomes slightly more dangerous. So there are a range of applications that we can use this to simulate near realistic situations for safety purposes. Emergency preparedness in buildings. We could simulate buildings and then use that to identify how building occupants are likely to navigate the building in an emergency, for the purposes of either training them or having facility owners to understand the behaviors so that they can design emergency preparedness systems a bit better in terms of signage, guidance, and then the rest. And the fact that we can simulate near realistic environment means we can do better risk assessment for sites. And one particular interesting one is a simulation of equipment operation. So if you see on the screen, we've got pictures of a simulator of a digger. So rather than training people on actual sites using real diggers with all of the risk, you can actually create simulators where you can train construction workers off-site and subject them to different types of risk. This is used very successfully in aviation, for example. So we all go in on airplanes and we are confident that pilots are very well trained. And one of the means by which pilots are trained to be able to navigate different things they encounter whilst flying is they use simulators. Although we don't use that as much within construction, but maybe we need to be, because construction happens to be one of the more dangerous industries in terms of occupational health. So these are just examples of how being able to simulate realistic visualizations can be used within construction to manage safety. So now let's go on to some of the research work we've done trying to use virtual reality for the purposes of improving construction safety management. So the first project I'm going to talk about is a project that we dubbed the Safe Crobot project. So this was a project funded by the EU Erasmus Plus program to be conducted across 4 European countries, of which the UK was part, and that I led. So at the time I wasn't in UCL, I was still in UWE, together with colleagues such as Professor Patrick Menu, as well as Dr. Abinesh, who spoke to you earlier. So what was the rationale for this project? So the Safe Crobot project was a project that recognized that on construction sites these days, there's increasing use of automated equipment. So we're either using robots to support us with some operations, or within the sites, or also within off-site manufacturing plants. There are a lot of robotic devices that are being used to perform different operations in terms of developing construction products. And this sector is projected to grow very significantly over the coming years. So from the automation sector being about 78 billion or million words in 2024, it's projected that the construction automation sector will be worth, over 300 million by 2033. So it's a growing sector. And what it means is that we would start seeing autonomous equipment on sites more often than we previously did. Given the background that human machine interactions have been a major cause of risk on construction sites, it means when we start introducing robots, we need to understand how human beings are going to interact with those robots, because robots cannot do all of the work. Humans will still do some operations. So what is going to happen in construction is that we're going to have a lot of autonomous equipment working alongside human beings, but we do not appreciate those risks very much because currently we do not use a lot of automation. So what this work sought to do was to identify some of the human machine interaction risk associated with the use of autonomous systems within construction, and to be able to develop future training or safety management systems that would make it safe for human beings to interact with autonomous systems on site. And so there are a lot of issues that lead to autonomous systems failing or having safety issues on site. Some of them are mechanical, some of them are design related, some of them are installation related, but a lot of them are human or job design related. Okay, so how do you design your work environment, or how do you train the human beings who are going to interact with these systems in a way so that they can minimize the risk associated with those interactions? When robots are deployed in factories, as you would see on the left top of the screen, they are more confined and environment. So sometimes it's easier to manage them. So, for example, in the automobile industry or offsite construction factories. However, construction sites are more dynamic, like the one on the left bottom side of the screen, and you've got a lot of humans and human behavioral issues that make it complex. So the aim of this work was actually to understand those interactions. But it will be too expensive to do this with real robots, and also it'll be too expensive to train workers with real robots. So what we did was to use virtual reality to model construction sites and model those interactions in order to understand those risks better, and eventually to be able to develop training tools that could help construction workers to understand risk before they're exposed to these environments. So primarily, that was the aim of this research, to ascertain sources of risk in robotics or automated scenarios within construction, and to be able to develop virtual simulations that reflect it, for two purposes. To a simulated environment to be able to appreciate the risk and be able to plan, but also to be able to develop future training tools. This is an example of a scene where we developed a virtual environment where drones are used and interact with construction workers on a construction site. Through these simulations, we were able to simulate external environmental conditions, as you can see, such as rain, such as wind, to be able to see how operators are able to navigate this. So not in the real world, but in a virtual environment, because in the real world, it could be more dangerous and expensive. And also, that's another example of where we developed this to simulate. So anyway, this is just a video that shows you a lot of the different scenarios that we simulated. And some of the scenarios were around the use of autonomous aerial vehicles, which is drones, autonomous equipment, such as diggers, as well as autonomous vehicles for the transport of goods on construction sites. And if I was to play the video a bit further, what you would realize is that we had different scenes that we simulated. And in this particular one, we used it purposely to be able to understand whether or not construction workers or students could appreciate the risk by playing the simulation or being involved in the simulation. Okay. So these are just examples of the scenes and some text interactions that players used to navigate the simulation, as well as answer some critical questions on the simulation. So I'll move on. So that's just a demonstration. I'll move on. So beyond developing these tools, what we also did was to develop testing and evaluations. So in this particular one, we use very traditional methods of trying to portray or visualize risk on robotic interactions on sites. And then we also use virtual reality for different types of conditions, different types of scenarios. And you can see from the blue line that virtual reality consistently outperformed other traditional means of simulating risk. So that's just an example of how we found that this actually works better. So I see we've got only about 5 minutes left, so I'm going to run through the next couple of slides, maybe slightly faster. So this is another project. So also a project completed whilst I was still at UWE Bristol. So this was dubbed the Consave VR project. So in this particular project, what we were trying to address was the fact that a lot of construction site accidents occur because of visual attention deficiencies. So either workers haven't seen and recognized a hazard or a risk on a site, or they haven't seen and recognized a warning sign, such as safety warning signs. So we're trying to understand behavioral differences that affect workers' ability, as well as just human differences that affect workers' ability to recognize risk on construction site, as well as to be able to recognize warning signs. So again, we developed a virtual reality simulation environment to be able to test this, and incorporated eye tracking and visual analysis to be able to track in real time how attention is allocated when workers are visualizing construction site scenarios. So developed with some standard tools that are used within virtual reality, such as Unity 3D, which is a gaming engine, together with some additional programming. So this is the result of that work. So on the left is the virtual reality simulation. On the right is us extracting eye tracking data. So this includes fixations, scan parts, and even saccades. So how they are moving their eye and where they are focusing their attention whilst they are within the simulation, just to understand how warning signs and hazards appear to different people and the behavioral differences that affect this. So some of the results indicated that you can effectively monitor visual attention data and eye tracking data, and through some additional analysis, you would be able to classify different individuals based on their visual attention characteristics. And what this does is that you're able to understand where the gaps are for different types of individuals. So what types of safety signs are most effective for different types of people? So an example I would use is, so colors mean different things to people from different cultures. So for example, if a safety sign is in a particular culture, that indicates danger, there are other cultures where similar colors don't necessarily indicate danger. So this is what we're trying to find out. So what you see on the screen is output from the research, which is showing virtual environments and specific statistics about how visual attention was allocated in different areas of interest within the virtual environment. Additional machine learning was done on this data, and we were able to develop a model that's able to predict visual attention of different people based on the way in which they observe the safety training scenarios. Or to put it in other words, we were able to take the visual attention data, and we're able to accurately categorize the different types of people who were visualizing it at any particular point, which means this could be applied in the future for development of tools that help us in planning sites better in terms of visual management, warning signs, but also in understanding individuals better in terms of what is most effective in warning them on construction sites. So that brings me to sort of the end of my presentation. So based on some of the works we've done, it's quite promising what virtual reality can be used to do in terms of developing virtual experimental scenarios for us to understand human behavior when it comes to safety a bit better, but also future tools that we can use to actively manage safety on construction sites. So thank you very much for listening.
Thank you so much, Bro Abdul, for the very insightful sharing. Okay, so maybe we can take one or two questions from the students. If you have any question, you can unmute your mic or type in the chat box. Any question?
Thank you, Prof. Abdul.
No, it's my pleasure to
Yeah.
speak to your students again.
Yeah. Okay, class, please ask the questions. I already warned them, to ask a lot of questions. They just try to skip it.
They've probably been bombarded with a lot.
And then the topics actually from your side is quite what I call high technology. We are not into that kind of stage. But all the research from
Um,
abroad
I y-
usually into that. Yeah.
yeah, yeah, to be fair, I'm not even sure if it's so high. Um, I think it's maybe that it hasn't been applied a lot, probably in the
Yes.
Malaysian context,
Yes.
but I
Exactly.
think maybe we should start conversations around that, see where there are opportunities for us to apply
Yeah.
it.
Yeah,
Yeah.
true. By the way,
Mm,
I have questions about the application of the VR. If they want to use at the safety training, we have a lot
mhm.
of participants. A lot of the workers. How they can use the VR if the tools they must provide, the equipment, how many
The
they have to
equipment. Yeah.
for the
Yeah. So that's
company
it.
to have it.
That's an
Because,
excellent question.
you know,
That's an excellent
usually
question. I don't know if
the conventional, they have many people, many
yeah.
workers sit together, like
Yes.
30 workers, and then one trainer. So if the VR
Yes.
have one tool, one equipment, so how it works?
Yeah.
What do you
Okay,
think?
so that's a very, very good question. So I
Mm.
think if you think about VR replacing traditional classroom lectures, then you would need a lot of devices. And some
Mm.
people take that approach. Many of our universities in the UK, we have several devices for when we want a large group to do VR. Some of the
Mm.
construction firms also have several devices for
Mm.
large groups, but usually the application of VR is not necessarily for all of the class to be on the VR simulation at the same time. So you
Mm.
can have other lectures for group and then have specific exercises that individuals have to do, at their own time. In which case, and also sometimes it's you are training probably one worker to go and work in a particular scenario. So all you need is for that worker to use the device. So rather than training for everyone at the same time. But a lot of companies are buying several devices because these days some of the devices are relatively cheap. I don't know the conversion to Malaysian currency, but in UK context, there are a lot of devices that cost, let's say, a third of how much a mobile phone costs.
We
Yeah.
can like here we can get like
Mm,
300 pound for
yes,
one
300
VR.
pound, exactly.
Yeah,
Yeah.
yeah,
So
yeah.
for a big
That's
construction
here.
company, buying 10 of those isn't that's like two laptops.
Right,
you know
right, right, right.
so
Correct,
so so that's
correct.
one scenario. The other scenario is that a lot of the training we are talking about could also be applied to smaller groups rather than large groups.
Right, right. So they do by face, right? It's not like and a
Yes,
massive people.
i i,
Okay,
I
yeah.
think that's I think
So.
that's more feasible. Another thing is a lot of the VR applications that are being developed these days are something we refer to as multi-user, so which
Mm.
means different people can be in the same environment interacting with each other at the same time. Um, but
Ah.
but I think it's more manageable if it's a small group. So maybe 5 people, six
Ah,
people, rather than having, 20 people interacting at
right,
the same time.
right. Correct, correct.
Yeah.
Okay,
So I think
interesting.
there's a question in the chat. Says although VR has strong potential, how practical is its implementation in small and medium construction, considering the cost? Okay, so that's a good point. So in the UK as well, we found that two of the major barriers to its being used is cost and skills. Yeah. So for a small firm, the cost of investing in, all of their equipment. But I think more so the costs in um investing in the skills to develop the applications and the scenarios. Yeah. So small firms unfortunately cannot invest in that. So far, I think the bigger firms are able to invest more in VR, but I'm sure as it evolves and develops, it will become cheaper. And smaller firms might also be able to. But in the UK, most of the big firms rely on a supply chain of small firms. So they are able to provide training for the smaller firms who work on their bigger projects. So in a way, big firms can be the conduits
Contribute, yeah,
of
yeah,
the
channel it.
exactly of the transfer of the technology to the smaller
Correct,
firms using VR.
correct. Yeah, yeah, true. Okay, good point. Alright, thank you, Sonia. Okay. Anything else? If not, yeah, I think that's all because I
Doctor,
think to. Oh yeah,
Doctor, I have one question.
okay, that's good.
Yes, please.
Okay, I have one question regarding maybe for quality trainings. Have you guys applied this for your quality trainings? Because as for me, I thought like quality training is a bit very practical, very
Hmm.
conventional. So
Hmm.
what's your comment
Hmm.
on this?
Okay, so that's a good point. I think VR can be so we haven't used VR specifically for quality training, but I think it could be very useful because quality training in a way shares some similarities with safety training. Yeah. So one of the major things in quality training is procedure, sequence, conforming with the right procedure standards. And VR could help you in simulating that. So, for example, in terms of training workers, you could simulate whether they would use the right tool for the right operations before they actually go on site. And once they get used to that, when they go on site, they are likely to use the right tools and procedures. So, VR can be applied to quality training, although we don't have examples of it, but I can see how easily it can be applied in that scenario. So I don't know if that answers your question. Okay,
Yes,
fantastic.
yes,
Thank you.
thank you.
Yeah, I think yes. Any more else? Any other questions? No, but they have tasks, Prof. It's okay. I will advise them.
Yes, absolutely.
Okay. Yeah. So I think that's all, is it? Thank you
Yes,
very
I
much.
guess.
I
Okay,
Uh,
think I
so
think before we end, we take
yeah.
picture first, Dr. Lina.
Again? Yep. Okay.
Yeah. Everyone, turn on your camera.
Why our
Oh,
student is so lazy, Prof.
I don't think so. It's in the evening, so I'm sure it's been a long day for most students.
Yeah.
all right. Okay. For the second session, all right.
Your voice is very far, Dr. Nurul.
Oh, so sorry, my
Um,
at home, right? The
yeah.
line not clear. Yeah.
Oh,
Okay.
okay. All right. Smile. Okay. I didn't go to the next, I just go the first page. I don't know how many of them. Oh, meaning I thought there is a auto appear. Those who are turn on the camera, they will appear at the first page, but it's not. Okay, wait, one more. I go to the 7th page. We have all now fought. Wait a moment. But not all turn on the camera. Okay, page 5 now. Wait a moment. Okay, page 6. Smile. Okay, last one. Oh, the last one only Muhammad Anik. I don't know why you are in the page 7. Okay. All right. So I think that's all. Right.
Thank you. Thank you so
General.
much,
Thank
Prof.
you,
Abdul.
Prof. Abdul. See you in July.
See you in July. Thank you very much.
Okay. All right. Thank you very much.
All right.
All right.
Okay.
Okay.
So
Wait. The
before,
rest, please.
yeah.
The student, please stay because I have a briefing for you. For before that, please take your attendance in the U Future platform. Okay, and then for the class ECM 572, maybe Dr. Nurul forget to remind that all of you have the individual assignment, which is by having the forum, you carry 10%, actually 5% for the first collaborative teaching this week, and 5% contribute to the second collaborative teaching, the second next week, you know. So please respond to the, let me show you in the U Future. Let me show you, where is it? U Future. Can everyone see it? Can everyone see the screen?
Yes.
Yes, doctor. Okay.
Yes,
All right. So this is for the class ECM 572. Please pay attention, for all the classes, especially Dr. Nurul classes. We have three classes, right, from Dr. Nurul. So we have, I think this one I open to all, so you can respond to it. The one that you have to respond is under special lecture. Okay, this one under special lecture. This one is the previous one. So this one, please click. I don't know your dashboard how it looks like, but you have to respond to international collaborative teaching here. And please, I'm not sure how it works in your screen. You can contribute something, right? You can respond to this and have post, right? Like this, correct?
Yes.
Can you see it? Okay, so please respond whatever the key takeaway from the topics that has been delivered by our speakers, by our international speakers. So up to you, how is your presentation to respond to this forum, because we have today, how many speakers we have? Four, right? Correct. So you might highlight speaker one, speaker two, or maybe you highlight Dr. Abinesh, Prof. Abdul. What is the content about? So you can put your name and description. I think you can continue maybe, and then you submit. Sorry, not create here. Sorry, create the post here. I think your post will be automatically appear your name because you are the one who posts it. It's better for you to write here. I don't want you to attach the files. You got it? Here also you can do any kind of function. Play around with this kind of features. Some of them put in the table. Some of them use infographics. Some of them, whatever style you want to discuss here or deliver the content, the key takeaways from the speakers, please do it. Okay, but in one post. For example, we have four speakers. You have to highlight whatever content in speaker one, speaker two, speaker three, and four in one post. Don't repost it, separately. You got what I mean? Understand? So the deadline is tonight, 11:55 p.m. If you not contribute to this forum, you will lose mark for 5%. Understand? Because you have individual assignment. So this one is individual assignment. Understand, class?
yes, yes.
Yes, doctor.
Clear? So please
Madam,
don't
Doctor,
miss it. Yes.
about the commenting tu kan, do we have to like by slot tu ke? Kiranya macam dalam satu post tu, kita tulis slot pertama and then speaker mana and then slot kedua speaker mana.
Yeah,
Betul?
in one post only. Correct. Not
Or not
posting
by
4
each slot.
times.
Okay.
Not
Alright.
posting 4 times. Only one post, you can summarize it in one submission only. Okay?
Okay, thank you.
Understand? Understand, eh? Don't repost many posts with the same person. I mean, you yourself only one assignment for 5% summarize the, I mean, deliver collaborative teaching for this week. That's why I said you have to highlight all in the one post. Okay? Hannah, any questions?
Is it possible to make it in point or we need to make it in sentence?
Up to you. I already
Okay.
make it is the more I can see the contribution, how you deliver it. From some of them maybe put effort, maybe the way they I mean respond to the forum is attractive. They might get more, depends on how you deliver in the forum. If you put just point, your marks also in point. Understand? Doesn't mean you put in the sentence, you will get full marks. No. It must be easy to read and please avoid to make it in the paragraph. I prefer in the point but meaningful. Clear?
Okay, Doctor. Thank you.
Okay. All right. Any questions? So we will have a break. You can pray first. Okay. Then we continue at 8 p.m. Dr. Zima, can we pause the record and then we can continue?
I'm not sure. I never done that.
Hmm.
I think we can stop and continue later.
Okay.
Just now you said we can respond to any of the speaker